Yeah, if it's proportional, you do not have a b. So your equation is y is equal to mx or y is equal to kx. All right, you've also got to know the ratios are equal. That means every single time I do y divided by x, they're all the same. So that means y divided by x, same number. And we're going to say each time. That's the reason why I have y'all divide out on any time it's proportional. Divide out every single bit of your table. Because if it's proportional, it's going to be the same number each time. This is also going to pass through the origin. And what's that point again? 0, 0. And it's got to be a straight line. Now, these two things right here have to happen at the same time. That means I could have a straight line, but that doesn't make it proportional. It could go through the origin. Yet again, that doesn't necessarily mean it's proportional. It's got to be a straight line going through the origin. Y'all good so far?
Yes, ma'am.
All right, what about non-proportional? What kind of equation is that? So what is the equation?
Equation is y equals
mx plus b. Nice job. All right, any questions up to here? All right, what do you think the next one's going to be looking at the top? Ratios are not equal. That means y divided by x, different numbers each time. All right. So it does not pass through the origin. I heard. And what? It's not a straight line. So if it does go through the origin, it's not a straight line. And I'm going to put on here not always a straight line. And I want you to put on here, if it goes through the origin, not straight. B, straight. So if it has a B, it could be straight, but if it goes through the origin, it's never straight, so not straight. All right, any questions up to here? Okay, so how much does Dylan and Angela make per hour? How do I figure this out? Why do I divide?
Because they're trying to see how much they get for 1 hour per.
Yeah, I want per 1 hour. So, do 336 divided by 32, and what do you get?
10.5.
Okay, so if this is money, can I leave it like that? So what do I need to add? That it? You ever seen money look like that?
0.
Where do I put the 0? In front of the 5 or before the 5? Yeah, I want to make it $10.50. All right. So this is Dylan. What about Angela?
$10.
So she's just $10? All right. So now it wants to know, bless you, is Dylan's wage for 25 hours proportional to Amber's wage of 42 hours? So what we're going to do is we're going to set this up. So you ready? So we're going to do money per hour. Now, we got Dylan, who has 25 hours, and we have Amber, who makes 42 hours. So we already know Amber is 420. Now, what is Dylan's wage at 25 hours? Well, how much does he make per 1 hour?
10.5.
So I have $10.50 per hour. Now, how much would he make in 25 hours? Would I just add 25? Does that make sense?
No, it's 262.50.
So 262.50. All right, so let's go ahead and put this into your calculator. 262.5 divided by 25, and what do you get?
Divided by what?
The bottom number. It's always top divided by bottom.
10.5.
And then we already know Angela's is going to be 10, right? So are they proportional?
No.
You want to know another way you could do this? So we can actually cross multiply. So go ahead and multiply that. $10,500? All right, now I want you to go ahead and multiply the other two. So 10,500. Now, what do y'all notice about those two? They are the same. So, their rates are not the same, right? But the ratios are proportional. Because if you multiply your two red ones together and your two circled ones together and you get the exact same thing, that means that you could actually divide out 420 by 262.50 and 42 by 25, and you'll get the exact same number. Because those two ratios are proportional. Now, how much they make per hour is not. But their ratios are. So, this one's the rate. And actually, I'll change that color. Nope, that's just the rate. That's how much they're making per hour. And this one right here was the ratio. And those are equal. All right, are we having any questions on this? So the rate is like a one-time per hour thing. A ratio is this saying, hey, this could equal this. Because we have two fractions. Are y'all good there? You need to put that on silent or turn it off. All right, so what we're going to do here is we're going to do exactly what the little ratio says. So what is y divided by x here?
75.
And yes, I'm actually going to have you write out the ratio. So what's this one?
60.
60. What about this one?
55.
And this one?
52.5.
Remember, it is money because it's cost per hour.
51.
All right, so is that table proportional?
No.
Do you get the same thing every time? No. So 45 over 1 45. $90 over 2.
45.
135 over 3.
45.
By the way, if you double 90, you do get 180. So 180 divided by 4 is 45. And 225 divided by 5.
45.
So which table shows us proportional?
The right one. Table 2.
Table 2. How come?
Because it's all the same.
We get the same answer.
Yeah, the ratios are all the same. So ratios are, and we're going to use a big word, equivalent.
It's a big
It is, but it's a great math word because they love to use it everywhere. So if we're determining proportionality from a table, what do we do?
You y over x.
Yeah. Same number equals proportional. Yeah, I'm not English. I try not to use a whole lot of extra stuff if I don't have to. All right, any questions here? Are we good so far? Yeah? Okay, so first thing we're going to do is we're going to look at the graphs. And it does tell us that they are for the tables in the previous section. However, if I did not know that, just looking at these, are they both linear?
Yes, they form a straight line.
Oh,
They're
yeah.
both straight.
I mean, does that look pretty straight?
Yeah, it's kind of going down.
Yeah, it goes straight.
So we're going to say that both of these graphs are linear.
Line in.
Yep, line R.
Steroid?
Okay, so both of these are linear. Are both of them proportional?
No,
How come?
because one passes through the origin.
So which one is proportional?
Number 2.
Yeah, table 2. What makes it proportional?
Passes through the origin.
So to determine proportionality from a graph, so we got origin. I'm going to put origin. So it has to be a straight line. And pass through the origin. All right, any questions here? Graphs are the easiest ways to determine proportionality. It's literally a straight line, does it go through the origin? If it does, it's proportional. All right, looking at your table. Which one of these are proportional? Just looking at it, which one can you already tell me is proportional?
1.
So we got 7, 8, 9, or 10, just looking at it.
7.
How about this? What if I made all the numbers really big? With the exception of one table, which one could I easily just look at? No math required.
Number 7.
And,
Number 8.
and it's 8.
8. Oh,
Maybe.
Here's why.
it's going by 2.
I don't have to do any math at all. All I have to do is look for 0, 0. Anytime x is 0, if y is not 0, it's non-proportional. That means 2 of them I had to do no math. All I had to do was find x is 0. Unless y is 0, you automatically have a non-proportional relationship. If y is 0 and x is 0, automatically proportional, no math required. Y'all good there? All right, now let's look at number I guess that's supposed to be a 1 or a 7. I'm not sure. I guess let's look at number 1. That should be a 7.
I think it's a 1.
That's what I'm saying. It's a 1, but I think it should have been a 7. All right, so what do I got to do each time?
Divide y over x.
So remember, I got to do y over x. So what is that equal to? Negative 3 divided by 1 is? Negative 6 divided by 2 is? Negative 9 divided by 3 is? And yes, you have to check them all, because what if they throw out the last one and it's not negative 3? Negative 12 divided by 4. Negative 15 divided by 5. Now, after about the first 3, are you probably good? Yes. But do you want to double check? Yes. All right, let's look at the last one. So we know that one's proportional. Negative 1.5 divided by 1. 1.5. We already know this one's 1.5. What about 4.5 divided by 3? 1.5. 7.5 divided by 5? 1.5. And 10.5 divided by 7. All right, so that one would also be proportional. Now, could have actually divided and done all the other work? Yeah, I could have. But anytime you see x is 0 and y is not, don't even bother doing the division. It's automatically not proportional. Any questions on that? Fine. So origin in a straight line for number 11, so proportional. What about number 12? How do you know?
It has a b.
Where's your b? Negative 3. Remember, it's always where it crosses the y-axis. Number 13.
Non-proportional.
What should be then?
It is
4. All right. What about 14?
not proportional.
But it goes through the origin, though, right? Oh,
Not straight.
so not straight. What about number 15?
Proportional.
How come?
It goes to the origin and it's straight.
It's got to be both. And the last one?
Non-proportional.
And what should be?
4.
Questions. Because literally some of your tests will look like this. I'll zoom out though, you can see that. All right, I'm gonna let y'all do number 17 by yourself. And then I'll unfreeze it here in just a minute, and that way we can check our answers. How's that? To recap, we have heard proportional relationships do not have a B. Non-proportional relationships have a B. Proportional relationships, when you divide them out, are all the same. Non-proportional, they're different numbers. What do you got? Or what would you put your spin on it? So non-proportional do not have a B? I love it. Alan, what'd you put?
All ratios are equal to each other.
All ratios are equal to each other, especially in a proportional relationship. Stephen, what'd you put?
Proportional relationships.
Either or.
Also proportional. After proportional relationships equal the same number every time, while non-proportional relationships don't.
Lindsay, what'd you put? Just read what you wrote. It's good. Ah, come on. You can do this. I believe in you. You're right. That's why I want, because nobody else has said this yet. What do you got? Why not? It's right. Come on, you got this. You realize I'm not leaving until you say something.
Non-proportional does not pass the origin.
All right, for those of you who did not hear her, she said non-proportional relationships do not pass through the origin. Remember, if they do, what do we know?
What?
If they do pass through the origin and it's non-proportional, what do I gotta see?
If it's straight or a curved line.
So if it goes through the origin and it's supposed to be non-proportional, is it straight or curved?
Curved.
Curved. All right, y'all have the remainder of the time to work on your homework.